run our code and make sure that it works. So I'm going to take the test matrix here and just move it below. Let's print out what we expect for the, let's see, it's called search matrix. It'll take in the test matrix and the test target. Awesome. And then let's go through and let's test it against a different test target. Test target that isn't within there. So let's test it with the number 12 and see what happens. Let's run it. True, false. Cool. Let's see. True, false. Alright, so we have validated that it works against the test matrix. However, I think it's always safe to test against a few more. So test, let's say a test matrix of 157. See what happens if we print search matrix of the test matrix and number of 10, which isn't in there, and then let's copy this over and test it against a number that is in there. Let's run this again. Okay, so for some reason the first one is printing out a true, or sorry, the true, not false. This is getting confusing. So we can probably delete this and then expect it to be false, just to make it clear. Okay, so expected it to be false and then it broke on the 10. So okay, so Linux index out of range means potentially there's something wrong with how maybe the indices are generated. So the first thing I would debug is simply print out this is the index, and then print out this is the converted matrix index row column. Okay. Alright, so this is the index, and then this is the converted index. So for some reason it's trying to access row number 1, even though in the test matrix we pass in, it should be trying to go for row number 0 because it's 0 index, which means, why is it row number 1? So clearly there's something wrong with this generation. If we look at the code of the row, it should be index divided by number of columns. Oh, okay, so that looks wrong. So length of, it should be the number of columns. Length of the matrix just gives you the number of rows. So let's try running through that again. Awesome, so expect it to be false, and then it returns false right here. Set it to be true, and then returns true right there. Alright, so actually I deleted this, but let's take in what they also gave just to verify again after we fixed it that it works. I think it was value 3 is what we wanted, test with, and then 13 is the other value they had. So we can remove these, just remove the print statements, run through. This should be a true and then a false, which is awesome. And then we can test with like a few different edge cases. Let's see what happens when you run through an empty matrix. It should be false. A matrix with one empty row should be false as well. Cool. So that looks good. The last thing you should do to wrap up an interview is just to go through this time and space complexity. For space, because we're only using 2 extra pointers, it's considered constant time, which is the most optimal. And then the time complexity is, as we've discussed before, because it's a binary search, it's log the number of entries that we are searching through. In this case, we are searching through an m by n matrix, which means there are m times n number of entries in this matrix. So that means our algorithm is O of log m times n. So it's important to note that I distinguish between the number of rows and columns, and a lot of times when you run through time complexity for matrices, you should be doing that because I think the time complexity is highly dependent on how the matrix is structured. There can be a huge number of rows or there can be a huge number of columns. That's all dependent on 2 different variables. And that's a wrap on this question.